Hello and welcome. My name is Maria Ott. I'm a project manager at Fraunhofer HHI, and Fraunhofer HHI will be presenting the new video coding standard VVC. I would like to introduce you to Fraunhofer HHI's expert Benjamin Bross, who will tell us all about the new video coding standard VVC. First of all, I would really like to know, what is video coding all about then?
Thanks for the kind introduction, Maria, and welcome everyone. So video coding, video compression is a big challenge. You have a huge amount of data of uncompressed video that an encoder needs to compress down to 5 megabits per second in that example, which is a fraction of the original size, 0.4%. So challenge one is to minimize the bitrate for the compressed video, and at the receiving end, at the decoder, that decompresses the video to its original size, but due to the huge compression might experience loss in subjective quality. To minimize that loss or to maximize the subjective quality of the decoded video. And in the history of video coding standards, it started in '95 for HD video 20 megabits per second, MPEG-2, H.264, H.264, MPEG-4 in 2003 brings it down by 50% to 10 megabits per second. 2013, H.265, HEVC achieves another 50% reduction, brings it to 5 megabits per second for HD video.
That's already very, very impressive. And why do we even need another video coding standard?
Yeah, good question. For HD video, 5 megabits per second, given the today's bandwidth, might be already enough. However, if you look at current forecasts and analysis about the internet traffic, you see that 82% of the internet traffic is video. So almost every bit in the internet is coded video. So this is a huge amount that you need to handle and to manage. At the same time, you have a 12-fold increase in augmented reality, virtual reality content traffic, which is way higher resolution than HD video. So there you might need another compression. You have 7-fold increase in video monitoring traffic, and all this increased traffic and increased usage of video requires another 50% of reduction at least. So versatile video coding provides that, another 50% reduction of bitrate compared to its predecessor H.265 HEVC. This year, in July 2020, the standard was finalized within the standardization bodies of ITU-T with the video coding experts groups, VCAC, and the ISO-IEC standardization organization, which is the Moving Pictures Expert Group, MPEG, and these two joined together with a lot of companies from the industry, including Fraunhofer HHI, to develop that new video coding standard, which has also a focus, as the name suggests, versatility, to support a wide range of contents and today's media.
Can you elaborate a little bit more why the new standard is called versatile video coding? Yeah,
so I said that's to support a wider range of contents and applications, but to give you a little bit more detail about that, first thing is screen content coding. So apart from camera captured content, there is screen content. If you do screen sharing, nowadays you do a lot of online meetings where you want to share your screen. You do online gaming streaming. This is all computer generated content which has different signal characteristics. And there VVC provides the coding tools to efficiently compress that. You have tools that support streaming with resolution change. So adaptive streaming is where we are supported by VVC. Augmented reality, virtual reality is supported by different sub-picture regions, extraction of sub-pictures to represent the point of view in a 360 panoramic, and other features of augmented reality and virtual reality that leads to an increased coding efficiency. So yet again, data rate reduction for these types of contents.
So within that context, a 50% bitrate reduction at the same visual quality sounds very, very promising. And how is that achieved?
So it's achieved by a combination of a big evolution. The evolution is H.266 versatile video coding is based on the same block-based hybrid video coding principle, so the same coding principle since the previous video coding standards, and we further developed that and put that a little bit on steroids. So this is highly optimized, that classic scheme, but we also have new stuff. Fraunhofer HHI introduced For example, a coding algorithm that was when we proposed that based on neural networks. So due to feedback from chip manufacturers and hardware implementers, we managed to further simplify that. But the basic idea or the main principle of that technique is still data-driven and based on machine learning. So these techniques are new techniques in video coding that have been first introduced in a video coding standard. So this is a small revolution.
All right, thank you. Do you maybe have an example where I can see both standards?
Yes, sure. So what you can see here is on the left side HEVC encoded UHD, so 4K video, and on the right side VVC encoded, the same video encoded with VVC. If you compare these two subjectively, you don't see a quality difference. So we matched the visual quality of both. However, with HEVC encoding, it takes 11.3 megabits per second, while VVC takes 5.3 megabits per second. And this is over 50% less bitrate that VVC encoding takes for that.
That's really impressive. I can't see a difference. But since new algorithms are involved, this comes at a cost of higher CPU resources, right?
Sure, but also hardware CPUs gets more efficient over time, so we have a little bit more resources that we can use for video compression to achieve another bitrate reduction. However, this is unoptimized reference software, so the encoding has been done with the software that we used to develop the standards, which was not targeted to be used in real-world applications, but just to show the potential and the efficiency of that standard. And there is a difference between the encoding and the decoding side. So from the encoding side, with that unoptimized software, you have a factor of 10 more runtime to compress the video compared to HEVC reference software. For the decoder, you have a factor of 2 that is needed in runtime to decode the VVC video.
Okay, I'd really like to know, what about licensing though?
Yes, so what is the cost associated to that? And there's while the standardization activity was purely focusing on the technical aspects of the standards, where we contributed our algorithms, and there's an industry forum outside that technical standardization activity, which is called Media Coding Industry Forum, MCIF. And the MCIF, where Fraunhofer HHI or Fraunhofer is a member as well, that tries to get everyone who has intellectual property rights associated to VVC together to agree on a simple licensing model. So if you want to use that technology, you only have to licensing it gets as easy as possible. And this is the purpose and the main goal of the MCIF.
That sounds really, really good. I would really like to know, when will we see implementations of VVC encoders and decoders out there?
So software implementations, Fraunhofer HHI is working on that September 2020. So it's available now in software. Hardware implementations usually take a little bit longer. So I would expect in 1 year you would see first implementations and chips coming out. But software readily available now, and my colleague Adam is here to give you a little bit more details about our software implementation.
Thanks, Ben.
Hey Adam. I remember seeing your VVC decoder at IBC last year. Can you tell me a bit more about the progress you've made since then?
The main difference to last year's presentation is that last year we were showing an implementation of an intermediate version of the standard, which was just recently finalized. So this year is the first time we're showing the decoder for the actual final VVC standard. As you can see, we can decode UHD videos at 60 frames per second, as shown in the demo.
And this is done by your TV?
Well, this is done by a computer that's connected to the TV, but we can also run the decoder on a modern mobile device, like this laptop, with very good performance.
All right. And is there a way to get access to your decoder implementation?
Of course, it's actually freely available on GitHub, just as our encoder implementation is.
Wow, that's awesome. And what is the performance of your VVC encoder?
Let me show you some slides. Our VVC encoder is already over 70 times faster than the reference implementation, which is also reasonably faster than the HEVC reference implementation, so it's actually quite fast. Because of the speed up, we have slight bitrate increase compared to the reference implementation, but we can compensate for that using state-of-the-art subjective optimizations, which basically just improve the visual quality of the video. So to explain the slide a little, what we're showing is basically the working points of the reference implementation. On the far right, here you can see the curve of different working points that we can achieve with our encoder, single-threaded. And when we use parallelization, we can increase the performance even more. So basically, using 4 threads, we arrive at the over 70 time runtime decrease with respect to the VVC reference software. Of course, our implementation contains subjective optimizations, which further increase the video quality. And as explained, it's all freely available on GitHub.
Wow. Well, I would really like to thank you for the awesome presentation and also for the very interesting news for us that the encoder and decoder software is freely available for everyone. I'm really excited to see the changes that will come about after the implementation of your new versatile video coding standard. Thank you all for joining in and listening. Goodbye.